This conference will now be recorded.
So, good morning, everyone, and welcome back to a fresh new session on credit risk modeling. Wish you a very happy new year, and wish you a very great 2024 ahead. Now, as discussed, we will be proceeding with the, you know, we will be proceeding with the uh, question answers and the interview sessions, right? The kind of questions that come in the interview. So, we'll be discussing them, and based on that. And that will go on for the next 3 weeks. So there will be 5 classes that we'll take to discuss that, and then again we'll resume our normal discussions, right? So I'll just kind of go to the Google Drive. I have made certain updates over there, and I would uh, kind of want you guys to take a look at it. Okay. So what we have over here is, if I go to service offerings 1.1, go to video recordings, go to acquisition scorecard development. So I have kind of structured the acquisition scorecard folder over here into 3 parts, right? So one is on the data preparation and on the initial Excel exercises that we have done and we have discussed. This session contains the end-to-end SAS codes that we had developed till now, right? So all the videos are updated over here, and the segmentation analysis framework that we had discussed is kept over here, right? So you have 5 such folders being, like, the acquisition folder being restructured and updated, right? uh, and I am currently working on updating this IFRS 9 folder. So I've downloaded the sessions that we have had. I'll be uploading them over the next couple of days, so your drive will be totally updated, right? So use this drive only, a 1.1 drive location, for whatever, for all your references and studies, right? uh, okay. Now over here in this, okay, so over here I will create a new folder, 04 credit risk modeling validation interview preparations, interview questions. Interview questions. So over here what I'll do is, I will in this folder I will be creating the Google Docs and whatever the document format is. So your document will be saved over here, and you can refer to this document directly from the drive, right? So I don't need to, you know, kind of uh, like, I would not need to share and reshare it with you. So it will be there with you, and you can very easily you can use the document from this location. Hmm. Okay, I'll rename this. interview question sets, uh, uh, interview question list, statistics, right? So over here, what we are going to do is there are different sections under which the interviewers ask you the questions. So especially when you are uh, kind of applying for a model development or a validation role, there are different set of questions which are asked. So broadly, there are certain sections, right? So one of the sections will be, so sections in an interview in a credit risk modeling interview. In a credit risk modeling interview. So the first set of questions that they ask you is overall walkthrough of the CV. So obviously the CV has to be well prepared and you must have the section. So I'll come to this part a little later, right? So CV and soft skills. The second set of questions that they ask you is on basic statistics and econometrics. The third set of questions which would come under the model development or validation process. Then how would you develop a model? How would you validate a model? How does the variable reduction happen and so on? Or validation skills. Now, if you the role that you are applying for is an advanced role, right? Then you do have machine learning, supervised and unsupervised machine learning. And finally, what you would have are the software or ETL tool skill sets. So that will include SAS, Python, and Excel. VBA maybe a VBA optional. SQL, SAS, Python, and Excel VBA option. So these are broadly the framework that uh, under which your uh, interview is structured, right? Now from here, what we'll do is over the next 5 sessions, we will divide these questions, right? The key list of questions that generally comes from each of these sections, right? Uh, For the overall walkthrough of the CV and the soft skills, I'll keep aside sometimes. So I'll keep aside maybe the last session for this. However, for the other section, so what we'll do is we'll start with basic statistics, econometrics, uh, then model development validation, and then machine learning and tool skill sets. So we'll do it, or we'll keep machine learning for the fourth session, and finally, for the fifth session, we'll have the overall walkthrough of the CV and the soft skills. Right? So depending on the progress that we have, we will kind of arrange these sections. So let us let's start. So I'll start off with the basic statistics and econometrics. Now, within this basic statistics and econometrics, what are the first thing that we need to kind of understand is what are the key areas that we need to cover, right? So, the key topics. The first set of topics that we need to cover are the absolute and relative measures of central tendency and dispersion. Then we have skewness and kurtosis. Kurtosis would not be really like would not be very important for us at the credit risk level. At the credit risk level, one thing that we would ideally have or what we would want to assess is the skewness. Okay, and one more section that I had forgotten to talk about is the regulatory framework. Now, this is a very important part, the regulatory frameworks, right? So one thing that we have over here is sampling and statistical inference. And then we have the regression methodologies, predictive and classification algorithms. Right now, what are the predictive algorithms that we talk about? We talk about linear regression, OLS models, OLS algorithms. Then you would have the MLE algorithm. Then you have logistic regression, and you would have time series. Now, these are the key list of questions that or key areas from where you would get the questions. However, the importance of time series would differ, right? Or the extent to which you need to prepare for time series would differ based on the profile that you are applying for. So, for example, if you're applying for a scorecard kind of a model, framework time series would not really be a part of it. However, if you're applying for IFRS 9 or CCAR kind of a CCAR kind of a product interview, over there linear and time series would be more important than logistic regression. But at our level, while we are preparing, we need to be ready with all these uh, modeling methods, right? Now there are other methods as well, so but I'll kind of cover them under supervised and unsupervised learning methods. But over here, these are the three methods on which I would like to ask you questions. Like I would like to create a list of questions that come up. Right. So we'll start off with the list of questions. Now, when I say the list of questions, they may not exactly be ordered by these topics, or I can order them by the topics. That would, if that helps everyone. Okay. So central tendency and dispersion. Okay. So here goes the first question under this topic. Okay. Okay. So the first question that comes over here is, okay, the distribution of EAD variable is performed. It is observed that the standard deviation of the variable is greater than the mean. It is observed that the standard deviation is greater than the mean. What could be the possible? Is this a possibility? Is this a numerical possibility? What are your inferences about this occurrence, or about the distribution of the variable? So what are your inferences about the distribution of the variable? Now, if this is the question, so basically the idea of this question is that I have the EAD variable in my data, right? And what I have done is I have kind of generated the descriptive measures for this distribution, for to assess the distribution of the EAD variable. So what I see is that the standard deviation is greater than the mean. Now, if we think about the definition of mean and standard deviation, ideally standard deviation should not be greater than the mean, right? And numerically that's not the case. But if you have a distribution, right? If you have the inferences, like if you have a when you do the distribution of EAD variable, you see that the standard deviation is greater than the mean. So now the question is, what is this a numerical possibility? And if it is a numerical possibility, what are your inferences about the distribution of the variable? Yes. So who would like to go for this. See, the idea behind these sessions would be for you to interact, right, to give the answer so that we have a right or a wrong answer. Now the question that happens now, the way I like to do it is, when I give the question, I would want the house to interact, right, to give me the answers. There is nothing right, such as right or wrong answers. What is most important for you is to think at that spot on the interview. So what are your thoughts on this question? Now, this EAD variable could have been LGD variable, it could have been sales variable, it could have been any variable, right? So the crux of this question is that it is a continuous variable. Now, for a continuous variable, you are observing that the standard deviation is greater than the mean. So the first question that comes to me is that is this a numerical possibility? Nitin, would you like to go for this? Yes, please do think about this and someone give me the answer. Okay, so I have received a response from Neha. Neha says that yes, this is numerically possible, and this is possible when there are a lot of zeros in the variable. The answer is absolutely a correct answer. So according to Neha, the mean is closer to 0, but standard deviation has increased since we have squared the values. Exactly the answer. That is that's precisely the answer. That yes, it is numerically the variable has a lot of zeros, so that the mean is the mean reduces, and the standard deviation, because we are doing the square of the values and taking the square root for standard deviation, the values would explode. I mean, the standard deviation would be higher. Now, that's a numerical possibility, so that's the answer to the first question. Now, the question is, what are your inferences about the distribution of the variable? Okay, now this is where the trick to the question is. And the statistic as a distribution is left skewed, but over here the importance of the EAD variable is crucial, right? Now think about it, that when you are estimating the EAD for a set of records, right? So those records are either in the books of the bank and they are performing, or they are in the collections book, right? So ideally for an account which is either on the books of the bank and paying it or repaying the loan, the EAD can never be zero. And if the account is in the collections book, so it means that the borrower has defaulted and a collections is going on for this. So even for those accounts, the exposure, if the observed exposure is greater than zero. So if you are kind of predicting the EAD, right? Now EAD can only be zero if the account has closed down. Now if there are so many zeros in a data set for the EAD variable, such that the standard deviation is becoming higher than the mean, it means that there are many observations which is appearing as zero. Now, so many accounts cannot close off in 1 month, right? So it ideally, this implies a data issue with the EAD variable, that when the extraction was done, maybe there was some issues in that extraction, right? Hence, the reliability, completeness, and the accuracy of the EAD field is questionable when the standard deviation exceeds the mean. So, or basically, so it's wrong to say that it would always do that. It may indicate an issue with the EAD variable, because if the standard deviation is greater than the mean, it means there are many zeros which are there, and hence such that the variance is affected. So that possibly an indicator of a data issue with the EAD variable, right, or the source from where the EAD variable is extracted. Right, now this can happen, the same can happen with uh, you know with RWA as well. So because EAD and RWA are two very critical figures, right, this is a very specific check which is performed on the data, right? So it is performed on the, so this check is performed on EAD and RWA, right? So I am not writing the answers to the question. So for the answers to the question, you would require to download the recording and you can go through it. Okay. Now let's come to the next question on central tendency and dispersion. Uh, okay. Define coefficient of variation. I think you can unmute yourself and answer the question, and uh, you can drop direct answers in the chat box. You don't need to send any private messages, right? Because this is an open forum of a discussion. Both of us can, so any one of us can be wrong, right, it does not matter. We are all training ourselves for uh, you know for a specific goal. So any kind of an open discussion is always allowed. Okay, so Ajay has answered that even in the case of large number of outliers, both sides of the mean can cause standard deviation to be greater than mean. True, Ajay, but that outlier has to be also, if you have to have more amount of zeros, because if the number is non-zeros, ideally your standard deviation can be very high, but it would not be higher than the mean. So for the standard deviation to be higher than the mean, right, as far as my understanding goes, we must have multiple zeros so that the mean goes down and the average increases, right? So that's the standard deviation increases because you are kind of doing a squaring of the roots, and then you are you're doing a square root. So that's the way this discrepancy can arise. Okay, so the next question is that define coefficient of variation. Yes, how do you define coefficient of variation? Yes. Okay, so coefficient of variation is defined as the standard deviation
Tanmay,
by
um,
the mean. Yes, please tell me.
Tanmay, in these type of questions, we need to tell, what the coefficient of variance is or the formulas.
Sorry, Neha, I did not get your question. Can you? I think can you be a bit loud?
So this in these type of questions, the coefficient of variance, say. So in these type of
Uh-huh.
questions, how will we go ahead with these type of questions? Like we go ahead with uh, giving them the definition or
So if
giving
you
them the
have the
formula.
formula in mind, you can always
Hmm.
say the formula and add one line to explain the formula. So like I wrote that standard deviation by mean. Anil had reverted saying that it is a ratio standard deviation to mean, which is correct. And Shweta had also the ratio of the standard deviation to the mean, right? Now, the way I would like to define it is that it assesses the overall dispersion relative to the mean. So with in relation to the mean of the distribution, what is the standard deviation, right? So basically the idea over here is, so this is now one important question that they often ask you is that if you are using a coefficient of variation, why would you use a coefficient of variation, or where is it that you would use a coefficient of variation? Now if I'm trying to compare the variation across two groups, yet the mean of the groups are very different. So for example, can you explain an or any applications, or no, I'll use a case over here. So define the coefficient of variation. So let me put it as another question. Now it may often it can always happen that you are asked that define the coefficient of variation in a straightforward manner, or maybe they do not ask you the question like this. The question that they ask you is something like this, right? That I have a credit card portfolio. So the bank has a credit card portfolio. For giving CLI, that is credit limit increases, the bank has done three segments. The bank has three segments, right? One is a delinquent segment, one is the non-delinquent segment, ever non-delinquent segment, or let's say delinquent at snapshot segment, ever non-delinquent segment, delinquent once in the last 12 months, but not at snapshot. So these are the three segments that they have created, right? Now there can be more segments that are there based on utilization and everything, they can have these segments over there. So these are the three segments that they would have. Now the question that comes out over here is that a bank is willing to give, you know, a kind of a CLI, not only based on the lucrativeness but also based on the volatility of the segment. So basically, if you were to compare, I would give a higher CLI. A higher CLI will be given to a relatively less volatile segment, right? Now the question is, how do you compare the volatility in the segment? So when I say volatility, I don't mean the definition as in a stock market volatility. I mean the volatility in the default rates. So a very simple measure will be to compare is the standard deviation across the segments, but the mean of the segments would also be different. They would not be the same. So over here, delinquent at snapshot, ever non-delinquent and delinquent once in the last 12 months, but not at the snapshot. So these three segments will have three different average delinquency rates because they have been created as segments because their overall dispersion had the overall mean had been very different, right, or had been statistically different. So over here, a higher CLI will be given to a relatively less volatile segment. So the question that comes over here is that how do I assess, how do I analyze the volatility in the delinquency or in the default rates of these segments? So the answer over here is the coefficient of variation. Now you can use the coefficient of variation as a very simple measure to assess the the volatility in the segment. So you can just compare the standard deviation relative to the mean, right? So the use of coefficient of variation is to compare the mean across compare the standard deviation across groups where the means may be different, right? So that's how
And
this particular definition or this concept would work. So in my like in my own experience of in the in interviews, when I was kind of giving the role for a 3 to 4 years of experience, uh, one thing that I had seen is that they do tend to ask this question of coefficient of variation because while we are all very comfortable with concept of standard deviation, variance, mean, median, mode, and all these things, right? Coefficient of variation is something which is really underrated. We do not use coefficient of variation very frequently in our lives, right? So this is a part which is not really very uh, which is not captured in details. So this is one set of questions which can come up. Yes, I think someone was asking me a question. Please tell me.
Tanmay, I have a question. I was trying to ask, like, we can also find the volatility by using the standard deviation.
Neha,
Are we using?
Neha, can you be a bit louder? I cannot hear you.
Just give me a minute. I
Just give me a
Yeah,
minute as
is it
well.
fine?
Yeah.
Is it fine now?
Yeah,
Is it
it's better.
fine
Tell
now,
me.
Tanmay?
Yeah. Yeah.
Tanmay, so we can always use the standard deviation to find the volatility, right? Is it because of what we have discussed in the previous question? That is why we are using the coefficient of variance here? Because in data we can find a number of zeros, and um, the it may change the equation of how we use the variable. Is it?
Neha, can you just repeat your question once again? I'm so sorry, but I just lost it in between. Hello.
Yeah. Sorry, Tanmay. So I was saying
Not
like,
an issue. The issue was at my end. Please tell me.
then I was asking, like, we can always use the standard deviation to find the volatility, right? Like how different one segment is from the other. But are we
Hmm.
using the coefficient of variance because of what we have discussed in the second question? Is it?
Correct. Because if there are three segments, the mean of the segments could be very different, right? So, like, let's say there is a variation of two segments, two units in two segments, but in one segment the mean is 100 and in the other segment the mean is 10. So a variation of 2 in a segment where the mean is 10 is much higher compared to a variation of 2 units where the mean is 100, right? So whenever we are comparing distributions, it is very important that the standard deviation be assessed with relation to the mean. Hence, coefficient of variation is a basic statistical measure that must be reported. Always remember, standard deviation is, I mean, even though it's an absolute measure of dispersion, a dispersion should always be assessed in relation to the mean of the distribution, right? So in order to understand which distribution has a relatively higher variation, it is not a good idea to look into the absolute units, but you should look into the unit with respect to the overall mean, right?
Okay,
So
then.
that's
Yeah.
that's why coefficient of variation is generally used. Now, I will mention two organizations, right, who look into the very basics. One is ANC and the other is Barclays. These two banks, they test your basic understanding, they take your basic understanding very seriously, right? So that's something that needs to be taken into account,
Okay, Tanmay, thank you.
right? Because you can always say that the standard deviation is different and that's deviation, which is true. But if you are talking about coefficient of variation, the person on the other side gets to understand that yes, you do understand the fact that dispersion has to be assessed in relation to the mean or the central tendency. So that's what, right? Okay. So let's go on to the next question. Uh, okay. A credit card portfolio of a bank has the following product distribution: basic, advanced, gold, platinum, and uh, diamond. Now this is for high net worth individuals. net worth individuals. Right now, if a distribution, if a relative frequency, if a distribution is plotted, uh, or let's put it this way, what do you expect the distribution of the product wise, the distribution at the product level to be? What do you expect the distribution at the product level to be? So what shape, or what shape do you expect the distribution at the product level to be? So what do you think should be the product level? So how would the distribution look like? So try to assess the information first, right? Let us try to do that first. So the credit card portfolio of a bank has the following product distribution: basic, advanced, gold, platinum, and diamond. Now, what shape, and the diamond is applicable for the high net worth individuals. What shape do you expect the distribution at the product level to be? So if I plot the distribution of the product level for this portfolio, what shape do you expect the distribution to be? I am just talking in terms of volumes. Distribution to be in terms of volumes. Volumes. Yes. So is the question clear to us? Yes. What do you expect the shape of the distribution to be? Yes. What do you expect the shape of the distribution to be?
And
Okay. So Anil,
for each of them, right?
sorry?
For each of
No.
the
What I am saying is, no. At the product level. So the information is, what shape do you expect the distribution at the product level to be in terms of volume? So basic will have a certain volume, advanced will have a volume, gold will have
okay.
a volume, platinum and diamond will have a volume. So if you so on one axis you will have the product names, and on the other hand you will have the volumes and the respective relative frequencies. So how do you, how would the distribution look like? So the distribution will not be calculated individually for each, because each of these are categories in a distribution. So at the product level, so if I am looking at the distribution by the product types, I have basic, advanced, gold, platinum, and diamond. So I have five values. Five values have observations, and each of them will have a relative distribution, relative frequencies. So how would you what would you expect the shape to be? Okay, Tanuja says right skewed distribution. So Neha says normal, and Anil tells me basic card has left skewness in the distribution. So I get answer for all the three types. Now, Tanuja, uh, tell me, why do you think this distribution should be a right skewed distribution or a positively skewed distribution?
Yes, Tanmay. So basically, I think this it will be a right skewed distribution because we can we will get more of the people in the basic, right? So and then
Correct.
uh, as we advance, like there will be less
Uh-huh.
and less people in the more advanced, more sophisticated ones.
Absolutely.
So that's why I
Absolutely.
think we will have a right skewed distribution.
Absolutely, Tanuja. Absolutely.
Okay,
So over
thanks.
here, in this case, we spoke about the products, basic, advanced, gold, platinum, and diamond. Now, when I spoke about diamond, there was an information which says that it is applicable for high net worth individuals, HNIs. Now, this HNI is a very critical information when it comes to these kind of questions. It says that if the diamond is applicable HNI, what shape do you expect the distributional product level to be? Now, the proportion of high net worth individuals will be very small compared to the other four products, right? So, this applicable for HNIs. So, this will act as a tail value. So, you will suddenly have a very you know a very uh, a set of records which will suddenly create a upward bias in the limits and upward bias in the balances and so on, right? So so the shape, so basically, okay, let me put this as in terms of the limits and terms of the credit card limits, right? In terms of volumes, right, in terms of volume, uh, the applicable for HNI, the diamond product will have very less concentration, right? So, and if I look at the basics, at the basics, so the basic will have the largest of the volume and so on, right? So in terms of credit card limit or in terms of volume, so this HNI will create a leftward intent. So
Left skewed.
yeah, so in terms of volumes, what Anil said is correct. I correct myself that basic will have the highest distribution, so basic will be at the lower end, so it would be left skewed with respect to the basic product if and looking at the volume. However, in terms of the credit card limit and the balance usage and all, the distributions will be right skewed because this diamond group of people will be very small proportions, but the limit that they very high, and that will unduly undulate the distribution, right, in terms of volume and credit card limit. So in terms of volume, left skewed for volume and right skewed or positively skewed for credit card limits, right? So both of you are more or less are like correct.
Uh, Tanmay, I have a small doubt.
Yeah, tell me.
Tanmay, for example, one particular portfolio. Let's take a gold card. I have one
Okay.
customer and he have three credit cards, three same credit card numbers, loan numbers I had. Means that particular customer A has three credit cards for the same portfolio for gold card only.
Okay.
So now they have different credit limit. That means different credit utilization in each card. It's happen. Should while I'm for to develop any model, should I consider the max credit utilization or low credit
But
utilization, or
Anil,
otherwise I can take only, sir?
no. So Anil, generally at a retail level, right? If you have a even in your retail portfolio, retail credit card portfolio, an obligor will have one card of one bank. So, for example, let's say I am taking a gold card from HDFC Bank. Okay. Now, HDFC Bank will give me only one gold card against my name. He may upgrade me to one from one product into another, or within a given product, he can upgrade by limit. But in that case, the previous account is closed, a new account ID is generated, and the upgrade is given. So that is how this thing operates. So basically, even if I have taken three different like three cards with three different limits from the same bank, like one account is closed and a new account is created. So every time in the portfolio, my account ID is unique. It is not that I have three different cards of the same bank. I can have a card of a given category from three different banks, but at a bank at a portfolio level, my card will always be unique, right?
Got it, Tanmay, got it.
So I may have three different accounts in the same product having three different limits, but they are three different accounts. For a given account ID, it would not be the case that there are three different limits. Now, if that has happened, it means that the data has not been refreshed to remove the older account IDs and have the new account IDs. Right? Okay. So this
Yes,
is
yes.
one type of questions which come in. Now, the kind of questions that I'm asking you, my key objective is to give you a sense of the kind of questions that generally I have come across. Right now, no one will kind of quiz you on like exactly on these questions, but these are kind of questions which give them an understanding of how in details do you understand the concept of central tendency and dispersion, right? Into the how do you understand the concept of distributions. And another important question which generally comes in here is define the loss distribution of a bank. What should be the shape of the loss distribution? Now this is a very important question which comes in. I'm clubbing this under the central tendency and dispersion because there's a shape to the distribution. But otherwise this is a part of I can you can also club it under the regulatory sections. But I'm just having it under this. Yes. So what is the loss distribution of a bank? We have done this part.
Right skewed then.
It should be right skewed. But why should it be right skewed?
Because the unexpected losses are less. So the unexpected loss,
The
I mean, in
frequency of
all,
the unexpected loss is very less. However, their impacts
the
are
exposure is
huge.
very
So basically, yeah, but when you are saying this, you first need to define the loss distribution of the bank. The
okay.
so the way it should be structured, the answer to this question should be structured is you first define loss distribution, you define the x-axis and y-axis of the loss distribution.
Okay.
You mention that the loss that a bank earns can be broadly classified into two parts: expected loss and unexpected loss. And from there, you say that the occurrence of the expected losses are portfolio losses which arise from lending, and hence the banks have adequate risk management strategies to predict those losses. Therefore, the expected losses more or less are symmetrically distributed. However, the unexpected losses are losses which have very rare chances of occurrence, but the impact of the incidence is so high that the loss distribution is, you know, the loss distribution gets skewed. Now, because the frequency of the loss occurrence is lower and the impact is higher, so therefore the skewness happens at the at the right side. The loss distribution is more or less homogeneous in terms of the expected losses. Expected losses are more or less symmetrically distributed because they are portfolio losses. So defining the loss distribution of the bank, what should be, so that's how you first define the loss distribution, and then you say that yes, it will be right skewed, right? So this, the reference to the answer to this question is the IRB risk weight measurement document. So you can just take a look into this IRB risk weight. Now, having said these questions, observe one thing, that skewness refers to the extent of heterogeneity in the data, right? So if there is a heterogeneity in the data set, the distributions will either be right skewed or it would be left skewed, right? So these are the 4 or 5 key type of questions which can come in for central tendency and dispersion. Now, what apart from this, there are some key concepts that we need to know, which should be prepared, the definitions of which should be prepared. Set of deciles, quartiles, box plot, quantile plots. So these are all definitions. So these are different measures. Deciles and quartiles, deciles, quartiles, percentiles are the relative measures of central tendency. So we will discuss their applications more when we talk about model development, right? Okay. So deciles, quartiles, percentiles, box plots, quantile plots. So these are some of the tests, checks that you need to, measures that you need to understand, and obviously median and mode, right? Just keep in mind, you know how the calculations are done for these. Right? So these are the key topics, key areas from central tendency and dispersion. Now, my request to all of you is that as you start giving your interviews, you get some questions, right? So please come and update those questions in this particular folder, maybe in a separate document that you want to create. Okay, the next question that comes over here is probability theory and distribution. Now this is a very critical section. Given that risk modeling relies a lot on the understanding of probability and distribution, right? So therefore this is a very critical section that you would have. Okay, the first question that comes is that what is the difference between likelihood and probability? So what is the difference between likelihood and probability? Yes, anyone? What is the difference between likelihood and probability? Yes.
Um, Generally, Tanmay, probability is the ratio of favorable events divided by the total number of events. Here, the total number of events are fixed, and in that total number of events, I'm expecting some favorable events that will happen. That's the probability. In the case of
Okay.
a likelihood, I already had a data. I already conducted some test and some experiment, some mission or some model. I have that data.
Uh-huh.
99% times, 99% of the times, the same value is falling at the same region. In next experiment, I'm assuming that it's likelihood to be happen at the same point. That's how I
Right.
can tell that.
So basically, probability gives you the chances, ability, the chance of a certain outcome to occur, a certain favorable outcome to occur, right? So let's say I'm tossing a coin and I'm getting the like I toss the coin 100 times and I see that I get heads 80 number of times. So my probability of getting heads is out of 100 trials is 0.8. Right. So that's the chance of a certain favorable outcome to occur. Now likelihood is something else. Likelihood tries to assess the best data distribution from a given situation in the data. So for example, let's say I have a joint probability distribution. Now there are n number of trials, so I have the outcomes for the chance probability associated with each of the outcomes. Now, in likelihood, what I'm trying to find out is that what is the best possible distribution that I can obtain, or what are the chances of obtaining the best possible, or like what is the best possible distribution that can be obtained from a certain given probability distribution, right? So while probability is a chance of a certain favorable outcome to occur, likelihood is the process of determining the best data distribution given a certain set of specific certain of parameters which describes the describes the describes a specific situation in the data. So that is what the algorithm of maximum likelihood estimation does. So I'll come to talk about the maximum likelihood estimation a little later, right? So over here we have, okay, so this is the difference between likelihood and probability. Now the next question that comes over here is, uh, what is a random variable? Now this question may seem very simple and very basic, but this is one question which I myself have been asked very recently in a Big Four interview, right? So what is a random variable? So what is a random variable? What is a random variable? Okay. So a random variable is defined as a variable x which has multiple outcomes, and to each of the outcomes a certain probability is associated, right? So if you come to this particular section, in video recordings, if you come to this, so all these questions that I have discussed is there in this videos, you can refer to them. If you come to the theory of probability distribution, so in these videos, in like day 5, 6 or 7, right, I don't exactly remember, within this time you will have detailed descriptions on random variables and all, so you can refer to these videos.
Tanmay, so in one of your
Yeah,
video, in IFRS 9 video, you were referring to a random variable as an example. So you have shown like there are x1, x2, x3 up to xn. These are the values in a variable. Then you showed the frequency and then the relative frequency
correct.
of each of
So
the variable.
basically, a random variable will be a out variable which has multiple outcomes, and to each of the outcomes, there is a probability associated with it. And yes, if you look into those board works, I think the detailing of this variable is done over there, right? So, so just do have a quick look. Now, the question behind now asking you what a random variable is just a follow up. So it's to follow you up on two important concepts. One is the concept of an expectation of a random variable. So, what is meant by the expectation of a random variable? What is meant by the expectation of a random variable? And that is often followed by calculate the expectation for a Bernoulli distribution. Calculate the expectation for a Bernoullian distribution. The reason behind asking this question is the reason behind asking this question is that because Bernoullian distribution is a very simple distribution, right? They want to understand three things through this. One is, do you understand what is meant by an expectation? Now, when they ask you expectations, they do not uh, expect to know the technical formula from your end. They want to understand the concept, right? And when they ask you to calculate the expectation for a Bernoulli distribution, they want to understand whether you can actually use that mathematical formula to calculate this distribution. So often random variable and expectation, so 2 and 3 is often punched into one question. Not that it comes every time, but this is like, even if people are asking, people do ask you these questions, right? So what is meant by the expectation of a random variable? So expectation of a random variable is nothing but it captures the long run average of behavior of the random variable. So if there were n number of trials which were being performed, what is the average value that that random variable would generate, right? Now this is a very typical question. Also, one thing I would like to tell you is that when you are going for these interviews, right, just do a quick google up and just practice a few basic probability theory calculation. Like, there are four balls in a box, five, you know so there are three red balls and four uh, green balls. So what is the probability that I'll be able to get a you know I'll be able to get two get one green and two red balls. So these are kind of basic questions which they often ask you to solve, right? So this is one set of questions which would come. So for a Bernoullian distribution, so what is a Bernoullian distribution? What is a Bernoullian distribution?
One
P
which
of
has two outcomes.
Sorry.
so this is, I mean, this is a special case of you say binomial distribution. So Bernoulli distribution is NCX p raised to power x 1 minus
No.
x
Yeah.
and
So this
p.
is, I totally get what you are saying. You are on the right track. But if, but when someone is asking you for a Bernoullian distribution, Bernoullian distribution should not be explained as a special case of binomial distribution. Binomial distribution is when a random variable would follow a binomial distribution when the number of, so like when the Bernoullian trials are performed in number of times or replicated in number of times. So one single trial, every single random trial in a probability experiment is a Bernoullian trial, right? So this Bernoullian, and when you replicate the Bernoullian trial in number of times, you reach the binomial distribution. So this is a very important part of the interview question. When they ask you, they want to understand the, for both all these three two questions, right? All these, the what random variable, expectation random variable, and Bernoullian distribution, they would always want to know your intuitive explanation of each of these. Because if you are giving, a proper textbook kind of a definition, at times the interviewer tends to misread this as to believe that there is lot of, so this guy is someone who is kind of mugging up definitions, right? But so whatever I, so whenever, I would explain to an interviewer, I would want to explain them in a very intuitive manner, right? And that's my suggestion, that whenever you are explaining these concepts, expectations, Bernoullian trial, random variable, explain them with the intuition, right? Intuitively explain them as if you are explaining something to a class 6 guy. Now that gives a sense to the interviewer that this person on the other side has an understanding of this concept, whereas he may or may not know the bookish definition. So he can explain the concept. That means he or she has this understanding capability. So that's how kind of deliver things in the interviews. You don't, not always that, uh, it's not always that, you know hard coded definitions has to be given. So this is something which is there. So over here, uh, the important concept to understand is the Bernoullian trial. Read Bernoulli trials. Investopedia has a very good content on that. A very simple content on that. Okay, what is the maximum variance that a binomial distribution can have? Of a binomial distribution. What is the maximum variance of a binomial distribution? Yes, what is the maximum variance of a binomial distribution? The answer is a very simple answer. Yes. What is the maximum variance of a binomial distribution? Ajay says n by 4. Absolutely correct. Absolutely correct. And how do we reach to this? So we reach to this by solving the constant optimization problem. So the question over here is maximize NPQ subject to P plus Q is equal to 1. Right? So if you see this, NBQ is nothing but a so if I plot a level curve, it's a kind of a rectangular hyperbola, and with a P plus Q equals to 1 being a straight line, right? So the point where they may meet is P is equals to Q. So this function becomes maximum at the point where P is equal to Q. Therefore, so P is equal to Q where it is equal to half. Therefore, maximum happens at, for max variance is n into half into half is equals to n by 4. Right? So this is how the maximum variance of binomial distribution is computed. Very good. Okay. Now the next question that comes over here is, mm, okay. So over here I will list out some concepts. Bernoullian distribution, the Bernoulli distribution, the binomial distribution, Poisson distribution, the concepts of probability mass function, as well as density function for continuous variables, cumulative mass density functions. So these are some of the important questions that we need to look at. Okay. Uh, Explain with an example concept of conditional probability. So this is another question which often comes to understand that what are the concepts of conditional probability, right? So this is another important. So this is another question which is to be understood. And if you are talking about conditional probability, then the next question will be to understand what is the Bayes theorem. So Bayes theorem and conditional probability are two important points that needs to be taken care of, right? Now there are so many sections, there are so many portions which are there. Now if I'm talking about a distribution, so you have like so if I'm talking about distribution, you have there are many distributions, multiple distributions, but our objective is to understand how these distributions are being created, like which of the distributions are kind of relevant to us, right? Now for credit risk sections, for credit risk modeling, uh, you know for credit risk modeling, binomial distributions are absolutely important, right? So when you from here, when you move to the sampling sections, in the sampling sections you would see that chi-square distribution, F distribution, T distribution, they become excessively important, right? So so this is as far as the probability theory and distribution is concerned. So I mean, there are a lot of other distributions as well. I'm just, for the time being, I'm just kind of focusing on the binomial distribution and on the other concepts around probability theory, so that if someone is trying to understand your understanding of probability, basic probability theory, these are the questions that will come to you, right? And one very important thing, note, please practice some basic applications of classical probability theory. And over here we'll have Bayes theorem, right? So this is some, so these are the three things that we would have here, right? Now my suggestion to you is that as we start preparing these questions, as we start preparing the answers or the responses to these questions, so there will be areas, there would be gray areas which you feel may be looked into, may not be looked into, but yes. So with so as you keep on preparing your responses to these questions, right, what you would see is that there are some areas which you think has not yet been covered and should be covered, so we'll update the questions accordingly, right? Okay, so now let's look into another set of questions. So let's say, suppose x, where is the tilde gone over here? Suppose x follows a uniform distribution, means 0 and with 0 parameters 0 and 1, right? Calculate the probability of getting a number x less than equal to c such that where c is greater than 0 and less than 1. So the question that comes over here is that what is the problem, like what is the, so suppose x follows a uniform distribution, so u stands for the uniform distribution, right? So suppose x follows uniform distribution with 0 and 1, so calculate probability x less than equal to c, where c belongs to 0 and 1, u is the uniform distribution. So what is the probability? Probability x less than equal to c is what? Yes. So what is the probability of x less than equal to c for a uniform distribution? So there are two parameters 0 and 1, and c is a number lying between 0 and 1. So what is the probability of x less than equal to c? Devojit, Shaptaki,
Can you
Shweta, Anil.
repeat?
Yeah, sure. So the question over here is that you have probability x less than equal to c. So and c is lying between 0 and 1. The distribution is uniform distribution. So what is the probability of x less than equal to c? The probability of x less than equal to c is c itself for a uniform distribution. So this is a part which should be prepared very well. Uniform distribution, because uniform distribution is directly applicable when sampling is done, when the data is being broken down into development and validation samples, right? So suppose x is less than 1, so calculate this uniform distribution is this, so on, right? So this is the uniform distribution. So uniform distribution is a concept which needs to be learned very well, right? So at the end of, so by today's discussion we can see that there are some very some so we have been able to list out like some 10 questions, 11 questions on probability theory and central tendency, such like which I have seen coming into the interviews very frequently, right? So we'll the next thing what we'll do is we'll finish off questions on this part, the distributions, and we'll move to talk about sampling and statistical inference, right, next Saturday and Sunday. So our focus will be largely on understanding what are the key kind of questions that would come in, right? So basically, let's say I'm trying to build up a statistical framework on which says, like, on testing. So I know that, okay, what is the null hypothesis, what is the alternate hypothesis, what is p-value, what is alpha. So these are the questions that I need to know. What are the key kind of tests that are there? What are the questions around them? What are the steps of performing those tests, and so on. So this is something that we need to prepare, right? So that's more or less it. So let's take a pause here for the day. This question list is there on the drive. Please go and take it out and prepare your responses on these questions that we have discussed, right? On the size, quartiles, box plots, median, mode. So these are all concepts that you need to know, definitions that you need to know, and over here you have these distributions and everything which is there. So let's try to work on this. So basic statistics and econometric skill. So I believe we'll be able to finish this by next week. Then we'll go into talk about model development or validation skills, regulatory framework, supervised, unsupervised learning, and then we'll talk about SQL, SAS, Python, and so on.
Tanmay,
Yeah.
where can we find these hypothesis testing material? Can you please show one?
The hypothesis testing materials, right? So the
Yes.
hypothesis testing materials are, they should be available in the drive location, and you can also get them in my YouTube channel. The basic statistical methodology frameworks and so in that playlist. And also, what I'll do is I will get the wait. So before I close the session today, we have good 10-15 minutes till now. So basically, I'll just you know I'll just save this, get the documents from drive one for you. So over here there are documents which detail on the statistical measures, central tendency, dispersion. I'll move them. Okay, so over here I'll create these copies. I'll just make this changes. Row 5. Okay. So if you open these documents, right, so they are in your Google Docs, right? So these are full-fledged notes which are written with all descriptions and proofs and everything done over here, right? So similarly, if you open to the introduction to theory of probability and probability distribution, along with the videos, you can also see all the, so this is a very detailed note on probability, right? You have all statistical methods and all these definitions being defined over here. You have all the methods of probability which is described here. All mathematical proofs are here. Along with it, you have all of these basic sums which are there, which are also done on classical probability. So all of these things are kind of done, right? So for the sections that we have discussed today, right, all the 6 documents are uh, put it are like are kind of put on the drive, right? So if you try to find out the answers of these questions in those documents, you will get answers to all of them. So that's how it has been created, right? So I suggest we start with this. For the testing hypothesis documents, for testing hypothesis lectures, you can for the timing you can revert to my YouTube channel. On the other hand, I will upload all the relevant documents for testing hypothesis that are required for interview preparations, right? And along with videos and SAS codes, I'll work on them as well. So that's something that I think we would have over here, right? So is this approach clear to us, all of us, Neha?
Yes, Tanmay.
Okay, great.
So
So let's meet next Saturday again, and we'll take it up from there, right? So thank you guys. Thank you for your time, and let's catch up next week. Bye bye.